We're going to show you 3 application scenarios of xMapper in this demo. The architecture has a sequence diagram, 2 state diagrams, and a structure diagram that consists of components and connectors. Starting from the architecture, we can use xMapper to generate architecture prescribed code. xMapper separates architecture prescribed code and user-defined code of each component into different classes. Architecture prescribed code is automatically generated. We can open the generated code right from the architecture. All this code is generated. Note that the operations in architecture prescribed code are simply implemented by redirecting requests to user-defined code. A Java interface file is also generated for each component. This is a list of operations that the architecture prescribed code expects the user-defined code to provide. Now let's look at the user-defined code. It implements the interface that was just shown, and it maintains a reference to the architecture prescribed code. The programmer manually writes this code. Here's an example of how they may call the architecture prescribed code during this process. Now we'll show you the generated behavior code. The highlighted code below is generated from the sequence diagram that we showed you at the very beginning. Now let's make some changes to the architecture and show how xMapper can automatically map these changes to the code. We start from changing the structure of the architecture. We can create a new interface to a component, redirect a link, or remove a component and its link. Next, we're going to change the behavioral diagram of the architecture. For example, we can add a new state to a state diagram, create a new transition to this new state, and finally, specify which event triggers the transition. For a sequence diagram, we can remove one of the participants and related message. All the changes we just made are automatically recorded into an architecture change model. Here we see the basic structure of the change model. It has a couple of change sessions. We can expand the current change session to see all changes we just made. The current session is not mapped to code yet. Now let's get back to the architecture and start to map these changes to code. A configuration panel pops up. Here we can tune the mapping process for each changed architecture component. Different components have different parameters like the names of generated classes and notifications that are automatically generated. You can manually add a new notification as well. Say, we will create a new component later. Click OK, and the mapping process is started. The architecture prescribed code of all change components will be regenerated. Here is an example. Remember, there used to be 3 lines of code below. Now there are only 2 since we removed one message from the corresponding sequence diagram. In contrast, user-defined code won't be affected by code regeneration. For example, the code we wrote earlier is unchanged. xMapper will send change notifications to the user-defined code. As you can see here, the first 4 were automatically generated, and the last was written by us in the configuration panel. At this point, all the changes have been mapped to the code. In this scenario, we're going to show you the effect of change analysis and refinement of xMapper. In this example, we create a new component first, add an interface to it, and finally, remove it. If you check the architecture change model, these changes are still recorded, although they should not affect the code. This time, we select Map Changes to Code. Nothing happens. However, if you check the architecture change model, it says the mapping is done.